In this section, we will be discussing about the overview of object-oriented programming. Object-oriented programming, we have discussed the procedural language, etc. in the previous session. So, in this session, we will be seeing the object-oriented concepts more. We will be discussing about the software evolution, the evolution of the programming paradigm. It is just like this. Okay, so software evolution is like this: monolithic, procedural oriented, structured oriented, object oriented. Okay, in monolithic there is only one way of execution, one step, next step, like that execution is done. And in procedural oriented programming, we have created something that we have done in the previous session, that is the functions. We have created functions and we have done the programming depending upon that. Okay, and the third one is a structured oriented programming. Means what? We are the connection or the biggest the modular programming or the modular thing, or we have done what the entire program is structured or using the constructs or structures here in this structured oriented program. Structured oriented program. Another name for structured oriented programming is that we are using what the modules or different modules. We are designing the entire program as modules, and the modules will be interacted with one another. That is known as the structure oriented programming. So what will be the difference between the procedure and structure oriented programming? In procedure oriented programming, we are just using the functions. There is no connection between the functions and all. Data flows independently. Okay, structure oriented programming, we are defining what the entire structure, the entire program will be defined by the structure. And object oriented programming is nothing but it is a programming. The basic concept is the usage of objects in this object oriented programming. Usage of objects. Let's move on. So here we can see the difference between the structured and object oriented programming. It is main difference here. Okay, this is a major question. Function oriented. The structured programming is what? Structure oriented programming is what? The function oriented. Mainly it is using the functions. Okay, so main concept or main part or element of structured programming is function. Okay, and in this case, in object oriented programming, it is object oriented. Means what? The basic concept or main concept in this programming will be, or with these programs will be, objects. Okay, it produces the procedure abstraction. Means the procedures will be done or the functions will be there, and will produce this same interface to the called procedure. And here we have the procedure as well as data abstraction. Data also will be available only through what? Through some interfaces. Okay, and here in structured programming, it does not support the external interface, and here it supports the external interface. Means what? If we are creating the program, we can use that program as a which will be reused. Okay, here it is free flow of data, but here it is secure data, and the data also is very hidden, and we can make it hidden, and using some external interfaces only we can change it. Okay, it is also known as function oriented programming or FOP. It is also, this one also called OOP, object oriented programming. So these the following are the elements of object oriented programming. Okay, let's see that elements. Okay, before that let's see the definition of object oriented programming. Object oriented programming is a programming methodology associate data structures with a set of operators which acts upon it. It is what? It associate the data structure with a set of operators which acts upon it. Okay, so let's see the elements of object oriented programming. This is basically a 5-mark question or an 8-mark question. Okay, if they are asking as a 5-mark question, you have to explain at least 5 of these elements, or just one line. The rest of the thing you can mention it as 1 line or 2 line, like that we can mention. And if they are asking as a 10-mark question or 8-mark question, you have to elaborate with an example. You have to elaborate it. Okay, so first one is our objects, classes, encapsulation, data abstraction, inheritance, polymorphism, dynamic binding, and message passing. These are the main elements of object oriented programming. Let us see the elements in detail now. Okay, first we will see the objects. Objects are the fundamental building blocks of object oriented programming. These are the basic runtime entities in an object oriented system. So if you are seeing C++, it can be used for procedural oriented programming as well as object oriented programming. So it includes the concepts of both the programming concepts, both the programming paradigms. Okay, and here we can see this objects will contain data as well as functions. Okay, the object will be associated with data as well as functions, which defines the meaningful operations on that objects. Okay, so object is a real world existing entity, just like our point, triangle, shapes, what else, box, all those things are the existing entities, and object is an instance of a particular class. Okay, it's also known as, this object is also known as the instance of a class. So here in an object, if you are saying an object, it will contain the attributes as well as operations. Okay, attributes is nothing but the actual properties of that object. You can see, if you are seeing a pencil, what will be the color, the sharpness, and the length of that pencil. All those things will be what our attributes. Okay, pencil is one object, and that object will have the attributes like color, length, etc. Okay, and operation, what we can do using that object. Okay, different operations are what, if let's say using that pencil we can write. Okay, that is one of the operation. We can sharpen it. Okay, that is another type of operation. So if you are sharpening it, the length of that pencil will be reduced. Okay, so sharpen, write, all those things are known as what, the operations. So here is an example of a student object. Okay, let's we are first seeing the object of a student. So if we are defining a student, what are the different properties of a student? It will be ST, or one name will be there, student name will be there, student ID will be there, branch will be there, semester will be there. Okay, so and all these things are defining one student. Okay, and other things are what, functions, or what will say the behaviors, like enroll. So student can enroll. Okay, the student can get the display info, means the information about that student can be displayed. Okay, the performance of a student, result of a student, all these things can be associated with this student object. Okay, so these are just like the properties or attributes, and these are the behaviors of the student objects. Okay, now what is a class? This is a second element of object-oriented programming. We have seen the object. Okay, here the class is a collection of similar objects. Similar objects means what? Similar objects. These do not are of similar type objects. The students, okay, those whole students in your class that are of similar. Okay, and here in this case, class is a way to create, or it will be like a blueprint for creating the object. Okay, let's say these all are the houses. Okay, and if I am creating a blueprint and using that blueprint, if we are building the houses, the blueprint is known as the class, and all these things are known as the objects. All these houses will be known as the objects. The next element is the third element is encapsulation. What is encapsulation? You have seen the capsules. Okay, what is inside the capsule? We will mix different medicines to that capsule, and we will be eating it. Okay, so here what we are doing is the code and the data will be associated together in a single unit. Okay, this code and data will be associated, and it will be acting as single unit. Okay, and all these things, this data as well as code, will be safe from external interface and misuse. Okay, so this code and data can be accessed only through a external interface. Okay, encapsulation is nothing but if we are creating a class, okay, class with data as well as the functions, or data as well as the methods, it is known as what? The encapsulation. So encapsulation is done using the creation of a class. So here we can see the class student. The attributes are ST name, student ID, branch and semester. Different functions are enroll, display, info, result and performance. Okay, this is known as what? The encapsulation. And the fourth one is the data abstraction. What is the difference is there for the encapsulation as well as the data abstraction? Okay, in encapsulation is saying what? The data and the code as a single unit. Okay, that is implemented using what? Classes. Okay, here the data abstraction. The abstraction is a simplified view of an object, includes only features it is interested, and hides away the unnecessary details. Okay, so data abstraction means what? We can create the classes. Okay, we can create the objects which is having a private, protected and public ones. Okay, so private means what? These data or functions that we are defining private will be private to that object. Okay, so it will produce only a number of data as well as the code, the functions will be available outside of the object. Okay, it is known as what? The data abstraction. Now, how we are doing it, or how we are doing it in C++, how we could create the object oriented, that this basics, how we are implementing it. Okay, so in as you have seen already, the structures can be created using different data types. Okay, you are creating a different new data type, user defined data type, and we can use that. Okay, here what we are using is, we are associating the properties or the attributes and operations in a single class. Okay, the class, this is a syntax of creating a class. Class name, opening curly bracket, closing curly bracket, semicolon, and inside this we will be saying what the attributes and operations. These attributes are nothing but the properties of that class objects, and operations are nothing but the behavior of the class objects. Okay, so now here in this case we have created what previously we have seen that the student object is there, and in that student object we have the we have these all things. Okay, these are the attributes of this class student, and these are the functionalities or the operations on this class student. Okay, and here we can see the stack. Okay, stack is another class. Okay, it is having stack size and TOS, top of stack. Okay, and it is having three different properties, or three different three different operations, and we can see initialization, push and pull on this stack object. Okay, so like this we can create the class. So data encapsulation is done using what? The class. Okay, now the next element is the inheritance. So as we have we can see all people are inheriting something or another thing from our parents. All people will be inheriting something from our parents. Someone has got the eyes of their father, hair of your mother, like that we will be inheriting it. Okay, so like that if we have already created one specific class, we can create another class also, use extending the features of the same class. Okay, so it is actually the inheritance is coming here only because of this reusability and extendability of this classes. Okay, it will produce or it will provide the reusability and extensibility. This we will study in detail later. Okay, so this is a process, this is a definition actually. Inheritance is a process by which one object can acquire the properties of another object. Okay, so here what we are doing, we are creating one object which will be inheriting the properties of another object. So here in this example we can see one point is there and one line is there. This line is made up of points. Okay, line is made up of points. So this line is also known as what? The child class or the derived class, and this line is inheriting from the point. Okay, inheriting the features and properties from this point. Okay, this point is also known as what? Parent class or base class. Point is also known as what? Parent class. Okay, if we are mentioning point as a parent class, the line will be the child class. If you are mentioning point as the base class, it will be, line will be treated as or said as derived class. Okay, the next element is our polymorphism. We have already seen one of the way of producing the polymorphism in our programs, that is our function overloading. Same function name with different arguments. Okay, so here polymorphism means what? The same thing can exist in two forms. Okay, same thing can exist in two forms. So have you seen the puffer fish? If you haven't, please search for it, and you can see whenever it is frightened, okay, it will become it will change its form to another form. Okay, so this puffer fish is an example for polymorphism. The same fish can have two different forms. Okay, so that is known as the polymorphism. Or you can see the Greek gods can exist in both forms. That is in Greek, one is in Greek form and the one is in Roman form. Okay? So same god can exist in two different forms. No? So this is known as what? The polymorphism. So polymorphism in our case, in our object-oriented programming, is in short the ability to call different function by just using one type of function call. Okay, polymorphism means what? We can call the different function. In our case, we can call different functions just by using one type of function call. Actually, there are the different functions, but we can call it by using the same function name. Okay. So here, in this case, we can see the plus is an operator. Okay, plus is an operator if this plus is accepting 5 and 9, it will be evaluating it and will produce the result as 40. Okay, so it will be evaluating it. Okay, if the plus operator is applied to two integers, it will produce the result as an integer. Okay, and if this plus operator, if I am giving to a string, okay, it will concatenate this thing. Okay, str plus ing will produce what? String. Okay, and this plus operator can be applied to shapes also. This is one shape, this is another shape. If I am applying this plus operator here in between these shapes, it will produce what? Another shape. And here also the triangles can be this different triangles can be concatenated and will produce the result. Okay, so this is what our polymorphism, the same thing but different functionalities. The next element of object-oriented programming is dynamic binding. Dynamic binding is nothing but the process of linking of code associated with a procedure call at the run time only. Okay, whenever we are doing after this completing the inheritance only, we will get to know what is it. Okay, the code associated with the procedure call will be done at the run time only. The process of linking of the code associated with the procedure call will be at the run time. Okay, in this case, whenever we are calling a function, at run time only it will determine which function to call. Okay, it is known as the dynamic binding. The next one is message passing. Actually, it is nothing but invoking a operation on an object. Message passing is what? Invoking a operation on an object. Means what? It is just a method call or function call of an object. Function call or method call of an object. So this is an example of this thing, message passing. There are three different objects. Okay, faculty object is there, student object is there, management object is there, and the management object invokes a function or method which is present in faculty object, that is what? The performance. Okay, and this will in turn it is calling the function which is present in the student object. Okay, and this object will produce the result. Okay, it will produce the result and it will call the research function which is present in the student object. Okay, like this, these objects can interact, or these objects can interact with each other. So what is message passing? It is just the invocation of a method. which is present in another object.